Okay, so let's start. Welcome to IETF 116. This is the MPLS working group. So if you are not looking for MPLS, you might move to a different room. Today, Dave and I am sharing, and Tarek and Loa will be remote for that session. We have an hour and I think 5 presentations. Let's see. Yeah, note well. So blue sheets, please sign in even if you are on site, also for the queue management. And we have here also the links for Zulip and minutes taking. The minutes are shared minutes. So if you want to contribute, just use the minute taking tool. Link to agenda, meeting material is also uploaded. Yeah, and there are also the links to the new wiki and also for the GitHub.
We can't hear you.
Okay, better now? Yeah, good. Well, and now it stopped advancing. Okay, I lost the connection to the server. Let me try again. Come on. Tarek, can you take over while I'm trying to fix here my network problems?
Let me see if I can.
I don't have any internet now, it just disappeared. Let's see.
I'm having a bit of problem sharing myself, Nick.
Great. Pardon? IETF. Okay, I try this one. Oh no, I think it's coming back. Hang on. Yeah, I can't. Yeah, I can. Yeah. Okay, I'm back again, so let's try it again. Okay, sorry for that. So let's hope that this time it lasts a bit longer. Okay, we're still in the status update on agenda. So then we have, I think, 5 presentations of drafts. Altogether, it's only 1 hour for today, but there are some minutes left to, I guess, cover my connectivity problems. Yeah. So we have, in terms of status, there is no errata reported, no liaisons incoming and outgoing. We have no new RFCs. We have one document in RFC editor queue, and we have a bunch of, in fact, new working group documents. Some of them, or many of them, were already presented this morning in the joint session. So if you look, those are marked here red. So if you're looking for those, please look on the recording from the session this morning. Yeah. There are also five new individual documents, 3 also this morning, 1 today in this session. Let me skip that one. And also some remarks on editors and pen holders. I think that slide is was initially from Laura. So basically, so a pen holder is the person who is basically doing the updates on individual draft, and that is being agreed by all the authors. I guess that's valid for all changes in drafts. An editor for individual documents itself is not really necessary, but of course it can be done if necessary. And if you are looking for, or the working group chairs can appoint a person to become editor of a draft, for instance, if we need to do changes and the original editor disappeared, or we have to basically restart work on a draft. Stuart?
Yes, if our AD is in the room, could they possibly comment on the length of time that SFL Control has been in their queue but unopened?
On its way.
Happy to. Stuart, there were a number of documents in my queue along with a whole bunch of others. There are a bunch of documents that right after this are going to be going into last call. I need to check the exact status, but I am planning on putting a whole bunch of documents into last call right after this meeting, and a whole bunch of other things onto the IESG agenda. So you should see something there in the next week, going into next week.
Okay, thanks. Okay, so coming back to the agenda, I think we will move to the first presentation today. I think that's you, Tarek. Oh no, sorry. It's David, I guess. Let me share. Yeah.
Good afternoon, everyone. Now I'd like to take a look of and introduce the draft MPLS T3RSVP state update for version 5. Before I start my introduction, I'd like to give some additional illustration for the draft. And first, this is not a new draft, and it has more than 3 years. And frank to say, it is EXO draft, just like EXO brandy, such as Matteo and Remy Martini. Now, I'd like to give the reason why I want to introduce such old draft in this meeting, because several years ago, I asked the WG chair to allocate a time slot for introducing this draft, but he told me then we have missed the deadline. So we plan to introduce this draft on the succeeding meeting, and a certain event happens. And then we have missed the succeeding several meetings of IETF. That's why we want to introduce the old draft in this meeting. Sorry for that. Then I'd like to give a brief introduction for the draft. Next slide, please. Yes, this is the problem, and this draft I want to address. about the the technical applied in the large scale application scenarios. The scaling problem are linked to the resource requirement in terms of processing and memory of running RDP, then RDP for MPLS network. And the resource requirement increase proportionally with the number of sessions. Each session requires the generation, transmission, reception, and processing of RDP paths and RESV message for refresh period. So support a large number of sessions, and the corresponding value of refresh message present a scaling problem. So that's the problem exists in the VR applications. Now the next slide, please. Then, to solve such a problem, we want to introduce a bit, then there's from the flank bit and the second bit of the flank, and replace the refresh message disable. When this bit set, it indicates that this node is winning and capable of supporting the refresh message disable intention described. This bit is a meaningful only between RDP enabled. Then is in the two period of RDP, and we can share some information for disable the refresh message. That's the purpose for this proposal. Next slide, please. And because we have introduced such a mechanism, and maybe some other problem will occur. Then introduced and follows. Refresh messages are used to both synchronize state between RDP neighbors and to recover from lost RDP message. The reliability and the latency problem occurred. When a non-refresh RDP message is lost in transmission, that's the problem. So, an implementation then supports the technique must support the functional described in RFC 2961 and follows. The two mechanisms try to complement the problem brought forward by this proposal, and it must support reliable delivery of path RESV and the corresponding tail error message and specified in section 4 of RFC 2961. And it must support the transmission of all unacknowledged RSVP messages using exponential bankoff, and this is specified in section 6 of RFC 2961. Next slide, please. Then, in order to make use of the Halo session based on the node ID, then it is described in RFC 3209, RFC 5558 for detection of RWPT signaling adjacent failure. The Halo message format is described as follows, including the common header and integrity and Halo. This is the version of the Halo message. Next slide, please. And to summarize my introduction, I want to say the proposal from this draft seems very simple, almost too simple, but it can really works. So from our side, it is worth to be discussed and to be improved. And to the current situation of the draft, and present the function has been realized in some protocol system. However, more evaluation is needed. And the large-scale application scenario is going to be simulated based on NFV environment. And the large-scale deployment is going to build in concrete application context, that's the current situation. And to the next step, we want to solicit the comments on this proposal. And we also want to invite the engineers and the experts to taste on this proposal and give more implementation. And we also want to improve the draft based on the collected comments. That's all for this draft. Thank you.
Thank you. So comments, yes, Vishnu.
Pawan Biram, Juniper Networks. I did send out my comments on this draft to the list a couple of days back. I'll repeat that here. It's always good to see RSVP drafts being presented. But this particular problem statement is already resolved in RFC 8370 that was published in...
Can you speak a little louder?
So this particular problem statement is already resolved in RFC 8370, which is a 2018 published RFC. I do see some of the text in your draft is, I mean, it was reproduced from RFC 8370. So I don't see anything in this draft that is not already covered in that. There are implementations out there that have been deployed that are running this refresh interval independent RSVP from that particular RFC. So I'm struggling to understand why you're proposing this now.
Okay, thank you. Maybe I can write down your comment and discuss it with the authors.
Thank you.
Thank you.
I think there's also, yeah, Lou? You are next.
Having a little trouble being remote. I wonder if this belongs in this working group, if it was to proceed, and wouldn't be generally applicable and belong in T's, which I think has the remit for general RSVP extensions. Now, of course, if it's not going to go forward, then it sort of doesn't really matter, but something just to think about. Thanks.
Yeah, that's a valid comment because I'm also the voice of Loa today. He has audio problems. He also mentioned that because it's RSVP, it should be also shared at least with TIS and CCAMP. So, thank you. No other comments? So, Lou again? Or?
Yeah, I'm not sure CCAMP, it's not technology specific, so I don't think CCAMP is needed. Certainly they'll care about it, but I don't think they're needed. Thanks.
Okay. Thanks. Okay, thank you. So let's move to the next presentation. I will pull up the slides. Hang on. So Greg, yeah.
Okay, next slide, please. Okay, so in this proposal, we point to some issues with using MPLS LSP to bootstrap BFD session, as well as IP UDP encapsulation of BFD control message in BFD over MPLS. So RFC 5884 requires use of LSP ping to bootstrap BFD session. But there are some issues that are not really clear. One of them is the sequence between the remote node responding with a reply message and sending its first BFD control message. So our proposal is that first to use no reply, and then if the remote node is requested to reply, then do not include BFD discriminator TLV in its reply. So next slide. So here's the text that we're proposing, that sender should send reply to no reply. It may set reply mode to reply via IPv4 and must not reply via using the router alert. So this specific update is to be consistent with the working group adopted draft that proposes to deprecate use of router alert option in LSP ping. Further, we clarify the behavior of responder that it should not include BFD discriminator in echo reply. Next slide. Another thing that we would like, we believe that it's helpful to clarify is the use IPv6 address in IP-UDP encapsulation for BFD control message over MPLS LSP. So current RFC 5884 specifies that for IPv6, it uses IPv6 mapped IPv4 loopback range. It's 128/8. But this range in IPv6 is a routable range. So basically it defeats the purpose of IP-UDP encapsulation to prevent leaking BFD or any messages out of box, because it's not really a loopback. For IPv6, there is only a single loopback interface defined. So what we're proposing to say that for IPv6 type of UDP encapsulation of BFD over MPLS LSP, that address 1/128 should be used. But sender might use their IP address from IPv6 range that is IPv4 mapped loopback interfaces. This is will make it consistent with a proposal again in above mentioned draft that adopted by the working group that clarifies the similar use for LSP ping. And to exercise ECMP environment, different paths, so we clarify that entropy label should be used. Next slide. So we welcome comments, and we think that draft is pretty straightforward, and would like to ask for the consider working group adoption.
Thank you. Any questions, comments? So if not, let's move to the next presentation.
I think it's again me.
It's again you, yeah? Hang on. Yeah.
Yeah, we can go to the next slide. Okay, STAMP, or Simple Two-Way Active Measurement Protocol, uses the echo request, echo reply mechanism, and involves two actors, session sender and session reflector. So by its name, the sender generates a STAMP test packet, puts a timestamp, sequence number, some additional information. This packet received by the reflector. Reflector adds timestamp of the receiving the test packet, copies some information from the received packet in the reflected packet, adds its own sequence number so that their packet loss one way can be calculated, or if it doesn't support it, then packet loss can be only calculated on a round trip, and then puts a timestamp on while transmitting the packet, and then sender receives the reflected packet, associates timestamp of the start of the reception, or as close as possible. So thus, as a result, one-way delay in forward and reverse directions can be calculated, and depending on the mode of reflector, either one-way packet loss or round-trip packet loss can be calculated. Also, using this collected information, inter-packet delay or packet delay variations can be calculated. Next slide. So this proposes encapsulation, IP-UDP encapsulation of STAMP test packet and reflected packet over the MPLS LSP. So for IPv4 encapsulation, it's to use any address from 127/8 or loopback range. And for IPv6, it's a single 1/128 loopback address. To bootstrap this session, it could be communicated stamp session ID to simplifying the demultiplexing of sessions, and that to be included in LSP ping. Also, it can have the additional information on optional for their path determining the reflected packet reverse path. TTL has to be set to 255, and destination port in IP-UDP encapsulation of stamp packet to use either well-known port of 862 or any other port from the dynamic range that has been provisioned on both sender and reflector. Next slide, please. So the bootstrap parameters I already mentioned, that session sender can be bootstrapped using LSP ping in a way similar as BFD session is bootstrapped. And that communicates stamp session ID or SSID that simplifies their demultiplexing of stamp sessions. Next slide. Control reflected packet path. In some environments, traffic engineering environments, or like, for example, RSVPT or SRMPLS, it might be beneficial to control a reflected path so that to do measurements of delay and packet loss on different paths independently. Otherwise, packets will be sent over IP network, so that might be not that useful. And we are proposing to reuse existing target FAC sub-TLVs that already being defined in MPLS LSP parameters registry group. So they can be included in stamp TLV bootstrap. Next slide, please. And that also actually includes non-FAC TLV that is defined in draft IETF's Spring BFD. So it can specify their label stack for the reverse path. We welcome comments, questions, cooperation, and draft is pretty simple, straightforward. So we appreciate their working group consideration of adopting this work.
Jared Mach, Akamai. I'm curious, the response, from the UDP port, is that going to be coming out of a hardware path, or is that going to get punted up to the control plane path?
I think that is implementation specific. So okay. I'm familiar with implementations that do a lot of hardware assist. Definitely, and actually, if we go more into details of STEM protocol, we have an extension defined that is adopted, already published as RFC, that allows you to specify the way, because what's important here is how you obtain the walk-walk value, okay, and how you do the time stamping. Because basically, since the reflector, and actually it's equally applicable to sender and reflector, how you obtain, whether you obtain this in software or you have a hardware assist. So because if you can do timestamping consistently before you experience queuing delay, so that increases your accuracy of the timestamp. So then how you process the packet is not that critical, because you can measure really time delay of the propagation and processing on transit nodes, so that excludes your host delay.
Yeah, the reason why I ask is we've seen, in order to protect the control plane and protect the devices that we actually have in operation today, that we're in our normal operational environment, we're actually running out of the filter space and a lot of the hardware platforms. And so whenever we're talking about adding an additional port that needs to be permitted, that could potentially end up on the, the punt path or the slow path as well, that gives me an area of concern. And so I'm wondering if there's a place where we could, either share within some existing, LSP ping or other port range mechanism to go and prevent allocating a new port in the very limited firewall scale that many of the hardware platforms have.
I see. Again, so UDP port 862 has been assigned as a test port for TWAMP protocol, TWAMP test protocol, and it has been inherited by STAMP, because one of the objectives of STAMP was that to allow its deployment in a TWAMP light environment of unauthenticated mode. So here we just take advantage of this 862 port. But as I mentioned, I don't know if it helps. See, the purpose of using UDP ports from dynamic range was that to make it less detectable. But at the same time, we in IPPM working group, we realized that there is a benefit of simplifying provisioning and using well-known ports. So basically, two options exist. I don't think that really answers your question. Yes, but I don't see basically how it can be done, because we want to identify this as a performance monitoring protocol.
Yeah, it's something that we shouldn't factor in all of the current hardware limitations that we have today into future protocol design, but I think it's something that we need to think about as we're standardizing a new protocol and proposing using new port numbers, because there are bounds, at least on the equipment today, and if we continue to scale them up, some of the vendors automatically do the right thing, and other ones we have to spend, when you actually go to implement the operations of the protocol, you require a lot of additional complex work in order to configure the device correctly and be securely. And so I think it's something we need to think about as we define new port numbers.
It is very good input, because again, what we have in IETF, we have different protocols, and protocols means by identified by the unique UDP ports for fault management and performance monitoring, as in comparison to that for Ethernet OEM, they are on the same Ethernet type. So then the opcodes differentiate CCM from DM and LM, for example, or synthetic class measurement. So yes, that's more conservative there, but here we have what we have. We had some ideas of floating, of having integrated OEM, which will be unifying for fault management and performance monitoring. So we can have this discussion. I'm very much interested if you just reach out and we can talk about it.
So one more comment from Tarek.
I'm going to make it quick. We are using LSP ping to bootstrap the STAMP session. That's my understanding. Does STAMP have applicability to the other data plane technologies? And if so, how do we intend to bootstrap the session in those data planes, for example, IPv6 or or a side effect?
That's a good question, and I was thinking about it, but I need to just put it in writing.
Okay. Thank
Okay.
you.
Thank you.
Thank you.
So next is, let's see. Yeah, okay. Jeffrey.
Okay, so this is about implementing MLDP or RCVP P2MP tunnels using SRv6 data plane. A clarification upfront. Right now we are using this single draft to cover both MLDP and RCVP, but the reason is that we just want to get the idea out first because they are same problems. So eventually there will be separate drafts covering the MLDP versus RCVP. I'm presenting here on behalf of the co-authors. Next slide, please. Some background first. So in the Spring Working Group, we just finished the working group last call for SR replication segment or replication SID, where a replication segment is a logical construct that connects a replication node to a set of downstream nodes. Replication segment is identified by a tuple of replication ID and node ID in the control plane. In the data plane, with MPLS data plane, the forwarding state for a replication SID is actually identical to the forwarding states that we use for MLDP or RCVP P2MP tree nodes, where basically you have an incoming label that maps to a list of replication branches so that you know how to forward the traffic. With SRv6 data plane, the SRv6 SID is encoded with those three parts: locator, functional bit, and argument bits. Now, the functional bits in this case are the equivalent of the MPLS label. So when you get a IPv6 packet, and if the destination address, the functional bits will tell you that's how you're going to forward this packet. Next slide, please. Now, to set up a P2MP tree, specifically SR P2MP tree, the replication tree is basically a concatenation of those replication segments. Notice that those replication segments are installed on the tree nodes, not encoded in the packets. So this is different from Unicast's case. It is expected that to set up SR P2MP tree, a controller will signal individual replication segments onto those tree nodes. You either using BGP or PSAP or even other approaches like NetConvo or whatever. In this case, again, each replication segment is identified by that tuple of a replication ID and node ID. The node ID identifies the particular nodes which this replication segment is for. And the replication ID is a tuple of tree root and tree ID. Next slide, please. Now, finally, come to the why we're talking about this draft here. So if you consider an existing deployment of MVPN using MPLS P2MP tunnels, and then part of that P2MP tunnel is transitioning to SRv6 because the network is moving from MPLS to SRv6. In this case, it is good to keep using the MLDP FAC or RSVP session objects all through, even for the SRv6 part. And to do that, there are three options. One is to use BGP signaling from the controller to the tree nodes using MLDP FAC. That is already specified in a draft in the best working group. Another way is to use controller signals via the PSAP protocol. Now, finally, the option is that you keep using the traditional hop-by-hop signaling using either MLDP or RSVP, but now instead of the label, just use SRv6 SID because the data plane is SRv6 now. This, of course, is when you do not need to use the controller for tree calculation and signaling. Next slide, please. So to use MLDP or RSVP signaling to set up this SRv6 P2MP tree, it's pretty much the same signaling as before, where you had where you signal incoming or outgoing labels before. Now it's just the SRv6 SID, and now we do need an indication to say that this signal label in the RSVP or MLDP signaling is actually just the functional bits of SRv6 SID. That indication pin can be carried in the signaling itself, or it could be by provisioning. For example, each node all the nodes in the SRv6 network has consistent provisioning, saying that when you see a label in the MLDP or RSVP signaling, you know that it's the functional bits of SRv6 SID. And then on the border node where you have the MPLS and SRv6 interworking, then you need the provisioning on the per peer basis. That's the provisioning based approach. Another one is in the signaling itself. We will use some new objects or new TLVs to indicate that this is a SRv6 SID. Next slide, please. So this is an example of MLDP signaling. We first need the capability to in the P2MP capability TLV to show that, okay, this node is capable of supporting this new signaling of SRv6 SID. And then wherever we would normally use a generic label TLV to signal label, now we use a new SID TLV for that purpose. This is the proposed encoding of that SRv6 SID TLV. We have the SID value and endpoint and some locator or functional bits or argument bits offset and lengths. Next slide, please. Similarly, for RSVP, we will have the capability signaling in the hello message and then where we normally would have the C type 1 label objects. Now we will use a new type of the label object to signal SRv6 SID. Again, the encoding is very similar to the MLDP one earlier. Next slide, please. There are some details that were left out in the drafts. We will finish those, and as mentioned earlier, we will decouple MLDP and RSVP to track them separately. Of course, we appreciate the comments and suggestions on this. Again, the use case is that you have a SRv6 data plane for part of your network, yet you may still want to use the MLDP or RCVP signaling for the entire P2 and P tree.
Thank you.
Yeah.
Tarek?
Presentation. If I understood the use case for the proposal to work, you need the SR nodes to also support or turn on RSVP or LDP. So they need to be running RSVP and SR so that you can set up your LSP through the SR nodes as well. And if that's true, what is the added value of using the SR replication segment? Why not just do RSVP cross connect?
So there are cases where an operator may want to move part of its network to SRv6 only. They want to move away from MPLS for their choice. In that case, the MPLS label does not work anymore. We have to use a SRv6 SID. It's just part of the network, and the rest of the P2 and P tunnel can still be MPLS based.
That RSVP should be turned on everywhere in that case? So end to end, you have RSVP?
Yeah, end to end is RSVP, but going through a SRv6 core, or end to end MLDP going through a SRv6 core or whatever. Yeah, or it could be the SRv6 on the edge or whatever. Yeah.
Okay, I think there are no more comments. Thank you.
Yeah, thanks.
So that brings us, I think, to our last presentation. Yeah, Wei Qiang.
Oh, this is Wei Qiang from China Mobile, and we have two draft in this presentation. So this one is the encapsulation for Ampere's performance measurement with the ESPL solution. So next page. So this is the basic idea of the draft. It defines the encapsulation for Ampere's performance with the alternative marking solution. We hope to use extension neighbor 15, the basic extension header, and we would like to introduce a new indicator for the flow ID, and we will introduce the flow ID information and the loss bit and the delay bit and one type bit, so that we can use this for the Ampere's network to monitor the performance. Next page. So we have this extension header. We can provide three kinds of encapsulation. One, we can encap the flow ID in the transport labels, and the second, we can encap it for the before the service, and the third one, we can encap that in both level, such as the PW and the RSP layer, so you can monitor the both layers performance. So next page. For the provisioning, we can have two kind of a mode. One is manual mode, and the other is automatic mode. And the difference is the Flow ID provisioned automatically or manually by the controller or AMS. So next page. So this draft we have get the adoption about 3 years ago. So currently it have been stable. As I know, there are several big operators who have deployed this solution in their field network. In China Mobile, we have deployed the solution in our 5G backhaul solution. Now we are discussing the MNA solution. I just mentioned this draft are using the ESPL solution. I think the MNA is one kind of a CSPL solution, so that is different. But I think the current draft have been mature. But we also hope the similar solution can be a use case for MNA framework. Next page. So we have already asked for working group last call, and it's stable, and which also have been verified by the running code and large scale deployment. So it's ready for last call. Next page, we have another new draft.
Yes, I think I would just take from the queue the question.
Okay.
Because I guess it refers to that draft.
This is Fang Gao from Zhongguo Laboratory. Maybe it's a mature feature until now, but I'm still interested with the way you choose to identify these two type of transport MPLS and service MPLS.
Yeah, so the wire. Yeah.
These two kind of for the inspection, and it seems that it depends on the location of the flow ID label.
Yeah.
Is it in front of the service label or it's behind the service label? And we know that the ordinary for ordering, the egress node will inspect the service label of layer 3 VPN or layer 2 VPN. And here, if we make this flow label behind of the service label, and on a payload, it need to skip the service label and go to the deeply inspection to the flow label ID.
Yeah.
And so I'm wondering why at the first beginning, you would consider some other ways like a different value space for the label for these two kind of performance inspect. Maybe it can avoid inspect the service label on the P node.
Yeah, we just list some example. So as you just mentioned, in some network, maybe we will have something like a hierarchical LSP. So one LSP in one subnetwork. So for end-to-end, the PW is end-to-end, but it will transit several different sections of RSP.
Yeah.
So at that moment, you need the RSP level performance monitoring and PW level performance monitoring. RCP level for maybe one section, and the PW is for the end-to-end. But of course, I think it's too complicated. It's just an example and to show how you can use the Flow ID solution. But it's not necessary you implement it like that. Yeah.
Okay, thank you.
Thank you. I also want to relay a question from Laura about backwards compatibility using the TC field bits as flags.
Yeah, we have some discussion on that. I think currently in our draft there are some notes text, and when we have an adoption call, I think we had discussed the question, and most people believe that is okay. And we also have already have some other example which have been RFC, which are using the similar solution.
Okay, yeah, thank you. So now the next.
Okay,
document.
thank you. So this draft is similar to the draft we just talked. But the only difference is that currently we hope to use MAA framework to provide the performance measurement with alternate marking method. So next page. So in this draft, we are using the MAA substack solution, which defined in the MAA header draft. And we will reuse the data fields specified in the draft we just present. Next page. So the format for the RSE format C showing here is very simple. The key difference is that the Flow ID is 18 bits compared to the other draft that is 20 bits, because here the MAA opcode will take 7 bits, so that we can only have 18 bits for the Flow ID. According to my experience to use the solution, 18 bits is enough. It's big enough. It can support enough Flow ID for the large operators. So I think it's okay. And the other bits is the same, such as D bit for the delay, L bit for the loss. So next page. Okay, so I think we can ignore this one because we have a 0.0 version, and in that version we use a solution which have been dropped by the MAA framework. So we generate a 0.1 version, which currently compliant with the current MAA framework. Okay, next page. Okay, so next step, we hope to review, and any comments are welcomed. And yeah, that's all.
Thank you. So we have time for one question. The queue is at the moment empty. Okay. No questions.
Thank you.
Thank you. So that, I guess, closes the MPLS session. Thank you very much for great timekeeping. I think we are on the minute. And we will see each other in San Francisco. Thank you.